Okay, guys. Today we'll talking about one of the very important concept in the electrical current once again. That is batteries in parallel. So batteries in parallel is one of the very important concept, and also difficult concept also actually. This is the one actually in the electrical current. One of the concept which is difficult in terms of understood the things. So I'm requesting all the people, please listen carefully. So let's see, guys. Here I take one battery. So this is the battery I'm taking here. So this is the resistance of this battery R1, resistance of this battery R1, and we have V1 is that is the EMF of the battery. EMF of the battery E1, EMF of the battery E1, and which is connected, which is connected, which is connected a resistance of R2. So this is R1 is the internal resistance, and R2 also internal resistance. Have EMF of E2, EMF of E2, and I have to connected this one in the form of branch manner. I connected. Okay, guys. So now I am taking this is discharging equation I am comparing. Keep in mind that discharging equations. You should not see the people see my batteries in series or ideal resistance. One of the concept I did one video. Please go through that video. I provide the link in the description. Please click on that link. You will redirected to that link. So I am using discharging equation. So discharging means the current coming out of the batteries. Coming out of the batteries. So this is discharging equation I am using here. So let us say, guys, here I is the current here, and that the branching is happen I1. This is also I2. Branching is happen here, guys, I1 and I2. So this is also I1. This is also I1. So let us assume we put the names for this. Let us say P and Q, this one P and Q, this is also P and Q. Let us say this is the main branch now. Let us say X, this is also, let us say Y. So let us say Y, guys. Now let's see, guys, here. Let us say Y, and this is X, and we are using the. So let us say this is A, this point is B, this point is C, and this point is D, guys. So we have AB and CD is there, as well as XY also there, and PQ also there. Now what I am telling you people, first you have to see the first branch. So first branch is what, guys? P, and I am moving like this, X, and goes to C, and goes to D, and finally reach to the Y, and finally jump to Q. So I am moving this branch P, X, C, D, Y, Q. So I am taking first branch. So what is the value? How to apply the KVL for this? I am applying the KVL. So KVL I am applying here. So once you have to apply the KVL, so we have a battery. So battery is there. Where I have to start? So this is plus, guys. This is minus. This is plus. This is minus. I stopped at minus. Where I stopped, I am traveling. I stopped at minus. Keep in mind, guys, when you are doing the KVL, where you have to stop? Exclusively batteries, exclusively resistance. You have to start. We find out the voltage drop on that particular device, on particular electrical circuit component. Any one of it we have to do it. So according to that, so I am going with V1. So where I start? Minus E1. Before that, so how much potential drop at P? So P is the potential drop. VP. VP is the potential drop minus minus. So here is what? E1. Here is what, guys? V1. Why? Because I stopped at minus. I stopped at minus. That is the why. Minus E1. So here is also I want to find out the potential drop at R1. I want to find out potential drop at R1. So what you get? So current is moving in this direction, but whereas current is moving, I am moving in this direction. Whereas current is moving against me. So both are different directions here. So one is that I am traveling against the current direction actually. Both are different directions. So certainly we have plus value. Certainly we have a plus value. So IR. So IR. Certainly we have a plus value because of IR. Plus IR1 is equal where you are start. You give the point I start. So from this is come to this side. Vp minus Vq is equal to E1 minus IR. Yes, guys. So this is come to this side, and E1 and E2 come to this side. So what you get? Vp minus Vq is equal to E1 minus IR. So Vp minus Vq, potential between P and Q points. So V1 here. So V1 minus IR. So this is I hope I1 na. I1. Now I want I1. So what I have to do? So come to this side. This is come to this side and this is come to this side. So what I get? I1 R1 is equal to V1 minus. So from this I want I1. I1 is equal to V1 minus V by R. So very important. So first you get the current value of first branch. The current value of first branch you are getting. So first branch current value you are getting. Same thing I am applying for. I applied for second branch also. What is the second branch? P A B Y Q. So I am applying the second branch P A B Q in between Y. So now we are applying what we get. Once again VP okay. And where I stopped, once again I stopped at minus. So minus E2. So once again look there guys. So current is moving like this. I traveled against the current direction. So both I am traveling in different manner. So when we are according to the rule of KVL, we have a 4 rules is there for while traveling the circuit component. How to evaluate? So according to that, this is minus it. And R2 is what plus. Why? Because it is opposite direction each other. So I2 R2 is equal to VP. So VP minus EQ plus I2R2 is equal to 8. Now this is come to this side. This is come to this. Now what will happen? VP minus VQ. Potential drop at P and Q. Always potential difference V on. V plus I2R2 is equal to 8. Now we want I2R2. So I2R2 is equal to V2 minus V. So from this I2 is equal to V2 minus V by R. Say equation 2. Now according to Kirchhoff current law, what is Kirchhoff current law guys? Kirchhoff current law states that sum of incoming currents is equal to sum of outgoing currents. Now what is the incoming currents here guys? I1 plus I2 are the incoming currents. Is equal to outgoing current how much? I1. Outgoing current is I. This is according to KCL. This is according to KCL. So I1, what is I1? Already we derived. V1 minus V by R1. V minus V1 by R1 plus, what is I2 guys? Just now derived. V2 minus V by R2 is equal to I. Keep aside. Next, we have to divide individually. So V1 by R1 minus V by R1 plus V2 by R2 minus V by R is equal to I. So keep in mind guys, what is our equation? Our equation is very clear, recharging equations. So I already told the discharging equations. So what is the discharging equation? So the discharging equation is, should I go with here better? So the discharging equation is, what is the discharging equation? So the discharging equation E is equal to E minus IR. So when discharging takes place, electromotive force is more. According to this one, electromotive force is more. When charging takes place, potential difference more. Keep in mind. So we have to change this equation to this manner. Let's see guys here. I want to change. I want to transform that equation to this manner. So let us see what we get. V1 by R1. V1 by R1 plus V2 by R2. Okay. V1 by R1 plus V2 by R2. Next, what is the remaining guys? This is the one is the remaining. This is the one is remaining. I take a minus V as a common. I hope don't worry people. Minus V as a common I am taking. Minus V is equal to, next, what is the part we are remaining? 1 by R1 plus 1 by R2. 1 by R1 plus 1 by R2 is equal to what guys? I. So now what is the equation? First we have subject as V. Next V minus IR. So according to that, I have to change this entire part here guys. I have to change this entire part. So for that what we get? V into 1 by R1 plus 1 by R2 is equal to V1 by, shall I take LCM better? Shall I take LCM and do it some procedure? So R1, R2 is LCM. So what I have to get? V1 R2 plus V1 R2 plus E2 R1. Very good. V1 R2 plus V2 R1. Okay. And this is come to this side. So what we get guys? Minus I we have to get. This is plus I. Come to this side. What will we get? So this is come to this side. And this is go to this side. I hope you understood. So now V into 1 by R1 plus 1 by R2 is equal to V1 R2 plus V2 R1 by R1 R2. R1 R2. R1 R2. Let's see guys here now. Now keep in mind guys, this is the discharging equations. What is extra here? This is extra. This part is extra is there. Compared to this equation. I am comparing with this equation. This part is extra. So I divide with both sides. No issue now. I divide with both sides. So what I get? I divide with both sides. So V into 1 by R1 plus 1 by R2 divided by 1 by R1 plus, sorry, small snug. So 1 by R1 plus 1 by R2 by 1 by R1 plus 1 by R2. I am dividing on both sides. I am dividing on both sides. I am dividing on both sides. 1 by R2. Here also I am dividing. I am also roughing this one now. Because most space is required. Okay. Next, V1 R2 plus V2 R1 by R1 R2. R1 R2 by 1 by R1 plus 1 by R2. Okay guys. Next, minus I into 1 by I into 1 by R1 plus 1 by R2. So I hope you people are understood. So simple, what I have to do here guys, divide above 1 with what guys? With what guys? 1 by R1 plus 1 by R2. So I am doing this process. So this is one of the critical part. Everybody suffered a lot here only. So don't confuse you people. So I am trying to tell you that we have to find out the equation in the form of E is equal to E minus IR. That is our aim. For that I am doing all this process. So now let's see guys here. This is cancelled. So we have to get here I take LCM V1 R2 plus V2 R1 by R1 R2 by, now I am taking LCM here guys. So what I have to get? R2 plus R1 by R1 R2. Understood, I hope. So this is I am taking LCM. This part I am taking LCM. This part I am taking LCM. Here also I am taking LCM once again. So I into 1 by R2 plus R1 by R1 R2. I hope you people are understood. Now R1 R2 get cancelled, guys. R1 R2 get cancelled. So what we have to get? V1 R2 plus V2 R1 by R1 plus R2. Keep in mind R1 plus R2 still be there. Next here also what we get, guys? Minus I into, how to write down this one? R1 R2 by R1 plus R2. Keep in mind. So this is can I written as R1 R2 by R1 plus R2, I hope. So now let's look, guys, here. V is equal to V minus IR, SR naught, SR naught, SR naught. So this is follow discharging equation. V is V, and what is the V equivalent? That is the value. And what is the R equivalent? That is the value. Now I have to compare these equations. So what I have to get when you comparing these equations? What we have to get, guys? Now I want to compare these equations. So compare, you people. So E equivalent is equal to E1 by R2 plus E2 by E2 into R1 by R1 plus R2. So this is very important equation. R1 plus R2 is very important equation. Next guys. Next what do you want? R equivalent you want. So R equivalent is equal to R1 R2 by R1 plus R2. R1 R2 by R1 plus R2. Otherwise 1 by R equivalent is equal to 1 by R1 plus 1 by R2. Your wish here. 1 by R1 plus 1 by R. So like this, and resistance is there in our circuit. How to handle and resistance is there. How to handle? So 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus and so on plus 1 by R by N. That way we have to find out 1 by R1 plus. Here also equivalent resistance are there. How to handle? So E equivalent is equal to E1 R and last one plus En. Next E2 R n minus 1 plus and so on En R1 by R1 plus R2 plus R3 plus and so on plus Rn. So keep in mind, when you have a n resistors is there in our circuit, E1 Rn plus E2 R minus N1 plus another is there E3 R minus N minus 2. Finally what we have to get? En R1 by R1 plus R2 plus R3 plus and so on Rn. I hope people are understood. Let's see one example so that people are understood. I am taking same circuit only. Operate parallel. What I have to get? So E1 is equal to 20 volts, E2 is equal to 30 volts, and R1 is equal to 2 ohms, R2 is equal to 4 ohms. Let us assume, guys, I want to find out E equivalent. So how to find out E equivalent? So E equivalent is equal to, what is the formula? E1 R2 plus E2 R1 by R1 plus R2. So E1 how much? 20. R2 how much? 4. E2 how much? 30. R1 how much? 2 by R1 plus R2. 2 plus 4. So what is that? 20 into 4 80 plus 3 into 2 60 by 2 plus 4 6. So 140 by 6. That is volts now. This is the total EMF of the circuit. Next I want resistance. So simple, 2 is there, so simple. So R equivalent is equal to 2 into 4 by 2 plus 4, 8 by 6. So 4 by 3 ohms you get. So such a way we have to do the job, guys. So thank you.